the GT Mythbusters.
And today we're talking about siphons.
So siphons work through potential energy. All state of matter wants to be at the lowest energy state. So if you have a container of fluid with a tube, and the tube is filled with the fluid with no spaces of gas, the fluid will go up through the tube, then back down to get to a lower energy state. Now we're going to talk about Bernoulli's equation and the math behind it.
We set up our Bernoulli equation using these 2 points, one on the surface, one at the exit of the pipe. And these 2 points work out well because we know that the pressure of 1 equals the pressure of 2, which is atmospheric pressure. And we know that this velocity is going to be equal to 0. So this cancels, and this cancels. Also, we know that the difference between 1 and 2, the height, is going to be h. So knowing that, we can plug it in, and we get that V2 equals square root of 2gh. And we're going to plug that in to our volumetric flow equation, and we get that Q equals A square root of 2gh.
Today we've designed 2 experiments to test the equation we just derived. So the first will be changing tube diameters to see how it affects the volumetric flow rate. So we're going to have 3 different tube diameters. One is going to be a 1/2 inch, one's a 3/8 inch, and one's 1/8 inch. We're going to run them at the same height differential for 20 seconds each. The second experiment we're going to do is by varying the heights. So we're going to have one at a high height, a medium height, and a low height, and we're also going to run that for 20 seconds using the same diameter tube.
So for the first part of the experiment, we had varying tube diameter between a 1/2 inch, a 3/8 of an inch, and a 1/8 of an inch tube, keeping height the same, but varying the area of the tube. And we found that the 1/2 inch yielded much more water transfer as compared with the 3/8 and the 1/8. Alright, so in the second part of the experiment, we varied the height with the same 3/8 of an inch tube, and we held it high, medium, and low as far as the initial positions of the 2 milk jugs, as seen here, the height varying. And we found that the highest height difference yielded the most water transfer, whereas medium and the low yielded less.
So in conclusion, we have confirmed our myth. The math is confirmed, and the area of the tube, if you increase it, will increase the volumetric flow rate, as well as increasing the height will also increase the volumetric flow rate. Science!